Okay, I'm going to start talking a little bit about 2.4 calculus textbook on the chain rule. Here's what the chain rule is. If you're taking the derivative of a composite function, which many things can be, everything can be expressed as a composite function, you would do it this way. It would be f prime of g of x times g prime of x. Now I can write this in different ways, but if you have, like I say, suppose you have 3x squared minus 5 to the 12th. Could f of x be x to the 12th and g of x be 3x squared minus 5? Could anybody tell me what f of g of x would be? You take your f function, I'd have to call it x to the 12th. So I take my f function, and then I replace the variable with the other expression. Is that what I have over here? So it could be written as a composite function. So when you take the derivative, you do f prime of g of x. So f prime of g of x times g prime of x. Basically, I've always told you that it's derivative. If you're taking the derivative, I believe I've told you for most things, it's power times base to the 1 less power, right? Now I'm giving you the rest of the story. The chain rule, right here, times the derivative of the base. What's the derivative of this base? 6x, right? 6x minus 0. So 12 times 6, your derivative would be 72x times this base to the 1 less power. The only thing that's changing is now you're adding the derivative of the base. Now what it's going to do is it's going to change most of our formulas. Every formula we've given you for derivatives has been in terms of x. But we're still going to find d dx. Okay, but instead of x to the n, we're going to call it u to the n. And its derivative would be the power, the base, to the 1 less power, but times the derivative of the base. And that's going to hold true for everything we do, derivative-wise. I think I might have told you that the derivative of e to the x was e to the x. It was the only derivative whose derivative is itself. But what if it was e to the 2x? You find its derivative by e to the same power times the derivative of the power. Now, if the power was just x, its derivative would have just been 1. So I didn't lie to you. We gave you correct formulas for e to the x. But now it's going to be e to some other power, e to the u. Now, how about your trigs? d dx, the derivative of sine of u. Give me a moment, I'll write them all out. Okay, the chain rule is going to be in every aspect. Many times you use it in the power rule. Power, base, 1 less power times the derivative of the base. It might be e to the u, the derivative of e to the same power times the derivative of the power. Something you might not know is the derivative of natural log of u. And its derivative is 1 over u times u prime. It's also going to change all of our trig derivatives. Derivative of sine is still cosine, but now it's times the derivative of the angle. The derivative of cosine is still negative sine, but again times u prime, the derivative of the angle. Derivative of tangent is secant squared of the same angle times the derivative of the angle. Derivative of cotangent is negative cosecant squared of the same angle times the derivative of the angle. Derivative of secant, if it was secant x, it was secant x tangent x. So it's still secant u tangent u, but this time times u prime, the derivative of the angle. And the derivative of cosecant would be negative cosecant of u cotangent of u, again times u prime, the derivative of the angle. So these would be your 6 trig derivative formulas. So like I say, the chain rule is going to add something onto the derivative. It's the derivative of the base, or the derivative of the angle, or the derivative of the power if it's e to the u. Let's do some examples. Okay, we still have the product and quotient rules as well. So if you have the derivative of u times v, it'd be u v prime plus v u prime. Derivative of a quotient, use a quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So there is more. I forgot to give you the product and quotient rules. These obviously are your trig derivatives. This is your power rule. And these really are more for the transcendental functions like e to the u or natural log of u. But you do need these derivative formulas. I just created a bunch of problems where we're going to find the derivatives, just samples, no product rule, quotient rule, nothing too fancy. But to find the derivative of y, we call it dy dx. This looks like something to a power. So I might do the power times the base to the 1 less power, but then you have to do times the derivative of the base. The derivative of the base happens to be 7. 7 times 18 would be what? 70 and 56, I believe 126. 7x minus 5 to the 17th. Let me check my arithmetic. Let me make that a little clearer. Okay, if I had to find the derivative down here, the derivative of e to a power is e to the same power times the derivative of the power. So it'd be 3e to the 3x. If I had to do the derivative of natural log of u, it becomes 1 over u times u prime. So what is this derivative going to be? 1 over u times u prime. The derivative of 3x minus 1 is 3. So it'd be 3 over 3x minus 1. We're just finding derivatives. The derivative of sine is cosine of the same angle times the derivative of the angle. So I would write this as 3 cosine 3x. The derivative of cosine is still negative sine of the same angle, but now you got to do times the derivative of the angle. So it'd be negative 5 sine of 5x. The derivative of tangent is secant squared of the same angle, but then you have to multiply times the derivative of the angle. So that's 14x times secant squared of 7x squared. These are just some examples. We'll get some more challenging ones. Okay, some examples from the textbook in 2.4 would be these. Let's see if I could rewrite this. I don't know if you want to rewrite this. What I would do is rewrite this as this to a power. And what do you write it as? The power over the root. It's always power over root. So it's a third root, to the second power, so it's 2/3. We'll find our derivative by doing the chain rule. Power times base to the 1 less power, 3/3 less than 2/3 being -1/3. But now you got to do times the derivative of this base. So you got to do derivative of x squared minus 1, which is 2x. So when you rewrite this, do you know that 2 times 2 is 4, and you have an x and you have a 3 on the bottom? Now what does this mean? What's a negative exponent? It moves to the other side of the fraction and becomes a positive exponent. So its derivative is going to be 4x divided by 3 times the 3rd root of x squared minus 1. And that's example 5. Okay, to do like number 6, example 6, we could do a quotient rule, but I see either the numerator or denominator is just a constant, right? If the numerator or denominator is simply a constant, you probably can get by without the quotient rule. Can I rewrite this as this to the -2? So now when you take the derivative, you keep the -7 out as a constant factor. Then you do the power times the base is 2t minus 3, to the 1 less power, which would be -3, times what's the derivative of the base? 2. So you get 2 times 2, which is 4. 4 times 7 is 28. Negative times negative is a positive. And this would go on the bottom because it is a negative exponent. It has to change sides and become positive. Again, we won't take negative exponents as answers. For example 7 here, it's a product of two things. So I'm going to have to use the product rule. Before I do that, I might rewrite it just so I have them in terms of exponents. So this would be 1 minus x squared to the 1/2. Now it is a product, so I need the product rule to find the derivative f prime of x. That's why you put the little mark there to indicate f prime. So anyway, the product rule, you bring one of the factors down. So I brought x squared down, times the derivative of this part, which is power, base, 1 less power, times the derivative of the base, which is -2x. Plus, bring down the 1 minus x squared to the 1/2, the second factor, times the derivative of the first. What's the derivative of x squared? 2x. What I just did here was the product rule. U times v became u v prime plus v u prime, the product rule. Now I'm going to rewrite it a little bit and see how you like to factor it. You're going to give you a choice. I see a -2, or a 2 times a 1/2, which is a 1. And it's a negative, and I think it's a negative x to the 3rd, because you have x squared and an x. And what do we have here? 1 minus x squared to the -1/2, plus 2x, 1 minus x squared to the +1/2. Let me look at this just a second. At this point, I'm going to factor what's called least powers. Between -1 and 2, the really only common factor is 1. However, on the x's, which is the smaller power, x to the 3 or x to the 1? X to the 1. so I'm going to factor that out. Which is smaller power on 1 minus x squared? I see that in both of them. This is to the negative 1/2, this is to the positive 1/2. Which is the smaller power? Well, it would be the negative 1/2. So I'm going to factor this out, and we're going to have something in here. Now, I already have this out front. I already have that much of it out here, right? So really, all I need to know is x times what is negative x to the third. X times what is negative x to the third. I think it would be a negative x squared. If I multiply these, would it match the thing above it? I believe it would. Now over here, you took the x out. Okay, sorry for the interruption, but phone calls happen. Okay, x times what gives me 2x? Well, you're going to need a 2. And you also might need another one of these powers. Because what's negative 1/2 plus 1? Is it 1/2? So, what do I have? I have x divided by, this would be the square root. And over here you have what? You have negative x squared plus 2, and then minus 2x squared. Does that look right? So does that become 2 minus 3x squared? 2 minus 3x squared. So the derivative is going to be x times 2 minus 3x squared, all divided by the square root of 1 minus x squared. Now we got that by factoring least powers. If you'll bear with me, I can show you to get the same answer using radicals from, let's see, from this point. Would you agree that this is negative x to the third divided by the square root of 1 minus x squared? And this is 2x radical 1 minus x squared. Do you agree that these are equivalent? Okay, we'll assume they are. We need a common denominator, which would be this. And the negative x cubed is already over that. What does this one need to make that denominator? Well, it needs the radical divided by itself. So this gives me 2x times the same thing without basically the radicand. So if I distribute, what do you have? You have a negative x cubed, you have plus 2x, and would that be a negative 2x cubed? Well, how would that simplify on top? 2x minus 3x cubed, is that right? If you factored that x out of the top, would it match this? I hope so. Anyway, you can do it with least powers or radicals, your choice. I will emphasize this, however. You answer the question in which the form it's posed. Because it asks a question involving radicals, you need to have the answer with radicals. If they gave the question with fractional exponents, then you can leave your answer in fractional exponents. But please answer it in the way it's asked.